Good evening, dear students. Today we are going to learn in detail about the different methods used for separating the components of a mixture. Okay, what are different methods that we have already tabulated in last class? The methods used for separating the different components of a mixture are, it could be either sedimentation, filtration, evaporation, sublimation, or centrifugation, or separating funnel, or chromatography, or distillation, or fractional distillation, or the crystallization. These are the 10 important methods that we have to learn. In this, we have to learn what is this method. This method is suitable for which kind of mixture, and what is the principle behind this method, means why this particular method is suitable for particular kind of mixture. So that is basically decided by its principle. Okay, so once you understand what is the principle and what is the method, you can quickly anticipate this solution can be separated by this method or not. So those things we are going to learn today. So a student, the very first method we are going to start is sedimentation. Some of the figures I have taken from your book. Okay, so these things I will also copy and draw at the relevant positions. So very first method is our sedimentation. So right, what is sedimentation? Students, we have learned that sedimentation is nothing but if a mixture is left undisturbed for certain time, then its heavier component gets settled down at the bottom. So this sedimentation so you are going to take a mixture in any jar or anywhere. So this contain different component.
Sir, we should draw that
Yeah,
drawing.
right. Whatever I am drawing, you also have to draw. In very simplest form, I am drawing this figure. Exam में भी आपको ये draw करने के लिए आते हैं. So if the particle size is bigger one, this is not applicable for the smaller. So draw the bigger particle in this water. Then you will observe that the heavier particle, though even it is uniformly distributed initially, but if you leave it for a longer time, then these particles get settled at the bottom.
Unstable.
Yes. Then you will get all these heavy particle will be at the bottom. Even some of these water will also be there at the bottom, because it cannot be possible that only the sand is in bottom and all the water will be at the top. Okay, so these heavy particles will settle at the bottom. So these are the water. This is the water. So mostly water. Even very few amount of sand or the solid particle is also in the upper layer. So this is our sand particle. These are of the bigger size. Okay, these are bigger size. This sand particle, what we are considering, it may be a pebbles. So it is like this one. So these are the sand particle. Means you are taking the mixture of sand and water and you are keeping it undisturbed for a very long time. It will get converted automatically into this form. So sand and water mixture is kept undisturbed. Undisturbed means you are not touching this, you are just keep it in still condition for a long time. Then you will observe that the sand are heavy particle, they will settle down. So this sand, what will happen? Sand settled down at bottom. Why? Because of its
Weight.
yes, very good. Because of its more weight. More. Whether you use the term weight or in a strict sense it is its mass. Okay, because of its mass. So there is a difference between weight and mass that we will learn in physics. Okay, student. So the criteria for this is difference in mass. So आपको यदि principle पूछे कि what is the principle? The principle is the mass. So difference in
Heavier mass object goes down.
of different components of components of a mixture. So because of difference in mass, the heavy mass gets settled down.
Goes down.
Yes, settled down. Okay, it is this one. When they are left undisturbed, that is the principle. So only this much is enough. So आपको प्रिंसिपल में ये ध्यान में रखना है कि ये डिफरेंस इन मास के कारण जस्ट ये छोटा सा फिगर बना देने हैं. Where this can be used, where it is used means the that is called the application, or what are the uses, or what are the example. कि इसका एग्जाम्पल यदि आपको बताना है, मीन द सेम थिंग फॉर सेपरेटिंग हैवी सॉलिड इन लिक्विड. कहीं भी ऐसा यदि सॉल्यूशन नहीं है, यदि सस्पेंशन है, तो सस्पेंशन में हम यूज कर सकते हैं इन सस्पेंशंस लाइक sand or pebbles in water. वाटर में यदि आपके छोटे छोटे कंकड़ हैं तो आप इसे ऐसे छोड़ दीजिए, कंकड़ और जो सैंड पार्टिकल है ये बॉटम में सेटल हो जाता है. सो इसका एग्जांपल यही है बेसिकली. दिस इज द सो सेडिमेंटेशन, दिस मच इज एनफ. आपको ध्यान में रखना है व्हाट इज द प्रिंसिपल. इट इज द डिफरेंस इन मास. हाउ इज द फिगर? So initially these sand particles are uniformly distributed. Then this is the stage if the solution or the mixture basically left undisturbed for a longer time, then heavy particle will settle down. Any doubt in sedimentation? Then please ask. So student, yes, this sedimentation can occur only and only in suspension. It cannot occur in true solution or colloidal solution. So write down the limitation. means कहां आप इसे यूज कर सकते हैं या क्या कमियां है. Limitation means where this method cannot be used. It is not
in true solution
or true solution or colloidal solution.
Colloidal solution.
Not useful for solution, true solution or even colloidal solution. In the both cases you cannot use these methods. Okay student?
Because the particles dissolve.
Yes, their particle size are smaller and their weight are also not very heavy. It is possible that the particle size are very fine, say the iron dust or iron fine particle are in water, and if you leave it, though these iron particles are also very fine but they are very heavy, then it will settle at the bottom. Okay, but in the true solution like sugar in water,
Salt in
like
water.
sugar or salt in water, if it is asked can be used for separating salt from
No.
the water by sedimentation, no, it cannot be used.
No,
Can be
sir.
used for separating the cream from the milk, which is a colloidal solution, no, it
No,
cannot
sir.
be
No.
used because the cream particle will not settle at the bottom. Or cream from milk. So these things you have to keep in mind. So we cannot use for these conditions. So this is the limitation. Many a time limitation is also asked. So student, sedimentation means because of its heavy mass or more mass, it will settle down. So heavy particle settled down. Heavy mass or heavy particle gets settled down. But if the particle is not heavier, not able to settle down, then it cannot be used. Like sugar or salt, they do not get settled down, or the cream in milk, they will not settle down, so it cannot be used there. Okay, so this is the first method. Now let us go for the second method. So second method is our filtration. Students, this filtration is the other very simpler method in which we are using a filter paper. So a filter paper is used. TER ये वाला इंग्लिश चलता है यहाँ पे. So filter paper is used. So this filter paper is placed in a funnel. Then placing the mixture on the inner side of this funnel or in the filter paper, the component having a smaller size will go on the other side, while the bigger size particle will remain in the filter paper. So how is this, student? You have to fold the filter paper in this form. Means if you have this round, this is the filter paper. Okay, so this filter paper have to be converted into this form, okay, in the form of cone. So this is the cone of filter paper that you have to keep in mind. Now student, this filter paper have very fine holes. Okay, these holes are uniform, means of the same size. Fill it with the pores. These are called as pore or hole in filter paper. So these pore and hole are such that it can allow the particle of size smaller than this hole. So this filter paper is converted into this form. Okay, so this is our filter paper. Now this filter paper have large number of holes
Pores.
that will also be there on these surfaces. I'm drawing like this. A student, but this filter paper will not remain as it is, so it is placed inside a funnel.
Funnel.
This is what? Funnel. This complete funnel. Okay. Now the mixture is placed inside this. Mixture is again what? The water and sand.
And
So take this. Now the sand particle are bigger in size than the hole in this filter paper. So what will happen? This water will move here and only water particle is able to come inside. So water will come out and it will get collected somewhere.
solute must be bigger than the holes.
Yes. So this is the mixture of, right here, water plus
And sand.
sand mixture. So what is going to happen? The water is able to cross these holes and they will come down and they will get collected here. So lastly, this, what is collected here is the pure water,
Pure water.
no sand. Okay, student? So this is the method. So method is very simple, that the filter paper contain large number of pores which allows one component of the mixture whose particle size is lesser than the pore size of the filter paper, while the other component will remain inside the filter paper. So write down the principle. So what is the principle behind this?
Smaller particle will go down and larger particle will
Good.
stay there.
So the size of solute or solvent or difference in it is basically the difference in
Mass.
size. No, size means the volume, it is not the mass. Mass means weight, which allow the particle to just settle down, move downward. It doesn't mean it have to move downward, it have to cross these pores. Okay, so different in
Okay.
size of components. Of mixture. A student, so different in size, so a smaller size, so the component means component of mixture whose particle size is smaller than the pore size. Pores are what? These are the small holes size of filter. So whether you write filter or filter paper mean the same thing, will cross or pass through it. But the bigger size particle will remain collected in the filter paper, but bigger size particle component remain inside the filter paper, they or on one side of the filter paper. Okay, this is the principle. Where it is used, are you getting? Lastly, you will get the pure water on this side, but the sand will remain collected here. Okay, finally, so right here, finally, only sand and few amount of water will remain in funnel, remain in filter paper. Okay, this is the final. Means when all the water will come out, only the sand particle will be there, and if it is left for few time or few days, it will dry. So this is now where it is used, that is called as the application.
Suspension.
Very good. So it is in suspension, whose particle size is quite bigger. Example, sand
Sand in water.
in water. The same. A student, here we have to keep in mind what is difference between the earlier sedimentation and this filtration.
Sir, in sedimentation, mass was there.
Just wait. In sedimentation, we were not using any filter paper, but because of its mass, it was the heavier particle of the component was settling down. But in filter paper, we are using a filter which have the pore, and the smaller size particle that will cross it, means the water will cross the filter paper, but the sand will remain inside this funnel in the filter paper. Okay, student, it is this method. So it is so simple. Now what are the limitation? Again the same thing. So this cannot be used for this solution,
True solution.
or even if the particle size is comparable to the both solute and solvent, or particle size are same for each component. Example, if you consider this sugar in water, this cannot be used. Whatever the size of sugar particle, that is very small, and the sugar particle will also cross the filter paper. Or cream in milk, these cannot be separated by the filter paper, because the size of cream particle is also same as that of the water particle. Okay, so here this method cannot be used. Means these are the limitations. Sugar in water or cream in water cannot be separated, so this thing you have to keep in mind. Student, then how to separate the sugar in water and cream from the water? So if the sizes are comparable, but if the masses are different, then we are using centrifuge. So you may write here, when write on like note, when size are, means size of the different component of mixture are comparable, means nearly same, but masses slightly differ, even in slight amount, not very largely differ. Okay, but masses slightly differ, then we use which method? Centrifuge, students.
Centrifugal.
Good. Centrifugation. So this is important that you have to keep in mind. So the first method, what was our first method? The first method was sedimentation, which was based on the mass, heavy particle, and the next second method was filtration, which is based on different particle size. Now what is the next third method? Evaporation.
So can you show previous page?
This one, yeah, write it quickly.
Yes, sir.
So let us go for the evaporation. So what is in evaporation? Evaporation means if one of the component get vaporizes on heating while the other do not vaporizes, then this evaporation can be used. Can I go ahead?
Yes, sir.
Yes, sir.
So write down this third method, which is our evaporation. A student, so this evaporation is useful only when one of the component get vaporizes while the other do not vaporizes. So right, on heating, only one component vaporizes. Vaporizes means change into vapor phase, but
Vapor.
Gaseous state.
yes, but the other component do
Settle
not
or
changes,
freeze.
remain as it is. Remain as it is. Okay, means that do not vaporizes. So what is the method used? The method used, there is evaporation. How is this set up?
Evaporation.
You are going to take the mixture
Utensil.
into a disc. This is called a China disc. In this, you are going to take the mixture. So this is our water, and it contains salt. Salt is of the smaller size and which is uniformly distributed, so it cannot settle down. Therefore, sedimentation cannot be used. So these are our salt like NaCl, and whatever this blue that we are taking is the water, salt and water mixture. It is to be heated, so this could be an utensil also or a China disc also. So when this is heated over a flame, so for heating there is a special arrangement called Bunsen burner. So this is what the flame I am drawing. Okay, student. So this is the flame. This is your flame. Like your kitchen, you are getting the flame now, flame of this stove.
LPG.
Over that it is, this is your heater or burner. Burner, this you are taking. Okay, student. So what will happen? the water gets converted into the vapor phase and it will raise the vapor. Okay, so these are the water vapor. But the salt will remain in the disk or remain in the utensil, remain
So
unchanged.
this can be used in sugar and water solution.
Student, sugar get converted into carbon dioxide, okay, and water on heating. So sugar means sugar cannot be lastly collected. That is a chemical reaction basically occur when the sugar is heated. Okay, that we will learn in class 10th. How is that? So
Okay, sir.
therefore it is not suitable for recovering the sugar from the water. Though on heating sugar water mixture, very first time only the water get vaporizes, so the sweetness will increase. But if you just want to just collect only sugar from the water, you cannot collect that sugar. But if there is salt and water mixture, at the end only the solid salt will be there, all the water will vaporize. Okay, so not much suitable for the sugar and water. So for collecting sugar from the water, we are using crystallization. Rather than heating, we are going to cool the solution. That is called the crystallization. That we will learn later. So this could be our utensil or china dish. So it is this arrangement. I think in your book is also there. So let me take the figure from your book also. See, it is this one, evaporation. A student, let us paste it here. The same thing, but here this ink is taken rather than sugar and water. So whatever the utensil used is called the watch glass, basically the china dish. This is the beaker. So this heating is done indirectly, not direct heating, because on direct heating, this dye means the ink will disintegrate. The chemical reaction occur inside the ink itself. So therefore direct heating is not done. So this is the setup. So right here to here. This is the setup for, so this setup is for heating ink. ये इतने के लिए ही है, heating ink indirectly. यदि आप इसे डायरेक्टली हिट करेंगे तो इंक खुद भी डिसइंटीग्रेट हो जाता है एंड इंक आपको इंक नहीं रहेगा, ये नए कंपोनेंट में कन्वर्ट हो जाता है. लाइक सुगर को यदि आप हिट करेंगे तो वो भी कार्बन डाइऑक्साइड एंड वाटर में कन्वर्ट हो जाता है. So this is the watch glass, I mean, or even up to this much we can say. These three things are used for indirect heating. So this ink contain the water, so the water will get vaporizes. So the two component, the ink solid particle will get separated from the water particle. So this is evaporation. So what are the example? Let me write. Principle same as above. Whatever I have written at the top, this is nothing but it is the principle, means the rule on which it is based. Write down example or application. So very first is collecting the salt. So salt from water.
Water.
Like अभी आपको ओशियन से जो सॉल्ट बनाते हैं वो यही मेथड रहता है मोस्टली, सॉल्ट फॉर्मेशन के लिए हम ये मेथड यूज करते हैं. but crystallization is also used for formation, and crystallization give even better quality of
Purification.
salt. We will see later. Yes, that is more purified. Crystallization is also used for purification method. A student, the next one is what? Ink, or different component of ink. So write different, or write simply ink, or solid ink particle, or black or blue ink. They are mostly in the solid form. Students, you are there?
Yes, sir.
Yes, sir.
Okay.
Yes, sir. There, sir.
Good. Because on the other screen, for a moment, the connection was lost.
Okay, sir.
Okay, student. So, means separating the solid ink, this method is used. Okay.
This can be used for true solutions.
Yes, it is possible, but the volatility, I mean, only one of the component shall vaporize, like this salt and water. This is forming a true solution. Okay, so a true solution. तो ये आपको ध्यान में रखना है सॉल्ट को. आप चाहिए तो सुगर एंड वाटर को हम इसे नहीं सेपरेट कर पाते हैं. नॉट सुगर, so cannot be used to collect sugar from water. Why? Because this sugar, on heating, the sugar get converted into carbon dioxide and water. As on heating, sugar breaks. This is basically the chemical reaction occur into carbon dioxide and water. So though you were trying to get the sugar, but sugar particle will not remain there. What is this sugar? Student, this sugar is mostly C6H12O6. This is the molecule of sugar. When it is heated, if you heat this, not just normal heating, but largely, means very high temperature. Very high temperature. While you are heating, it gets converted into carbon dioxide and water. Okay, it is this one. So sugar particle get dissociated, therefore this cannot be used for separating the sugar from the water. Okay, student, this is what the important. This can be used for true solution or colloidal solution. इसके लिए हम इसे use कर सकते हैं. But condition is that only one of the components shall vaporize while the other shall not vaporize. This vaporization again takes place, means this vaporization takes place at their boiling point. So if one component have very high boiling point than other, not even 30 degree, but even more than 40 or 50 degree or 60 degree, then only use. So right, if you want to write only, or write simply like this. So boiling point of different component must be different or sufficiently different, or having sufficient gap. Different. ये बहुत ही ज्यादा अलग अलग होने चाहिए. आप देखेंगे तो यदि दो कंपोनेंट है, आप लीजिए सॉल्ट का एंड वाटर का, तो आप देखते हैं सॉल्ट वेपर में कन्वर्ट ही नहीं होता है, क्योंकि इसका बॉइलिंग पॉइंट 300-400 डिग्री सी होता है, बट वाटर का ओनली 100 डिग्री सी होता है. तो आप 400 माइनस 100 करेंगे, स्टिल देयर इज अ गैप ऑफ 300. सो इसे हम कहते हैं डेल्टा टी T is temperature between boiling point itself very large. Okay, even it should must be greater than at least 60 or 70 degree. तो ये यदि इतना ज्यादा है बॉइलिंग पॉइंट का डिफरेंस तभी आप इसे यूज कर सकते हैं. यदि ये इससे कम होता है तो आपको इस इवोपोरेशन को नहीं यूज कर सकते हैं. क्यों? क्योंकि दोनों का वेपर फॉर्मेशन साथ साथ हो जाता है. देन वी आर यूजिंग द मेथड कॉल्ड डेस्टिलेशन, वेयर when both the vapor are formed, then the vapor are cooled again, then one of the component get cooled easily or early. So that method we will see in the distillation and fractional distillation. So this was about our evaporation. Any doubt in evaporation? Then the student please ask, or let us stop the class here because I have to go for class 10. So tomorrow remaining we will try to discuss and finish it. So student, you have to keep in mind what means where it is used. This thing you have to keep in mind. What is the principle? This you have to keep in mind. So in this case, the principle is difference in their boiling point, means difference in their vaporization. Means vaporization occur at different temperature. How is the figure? If required, in your subjective question, you have to draw this simple figure also. Correct? So this way you have to learn. Now a student, write down the homework. Homework. A student, whatever this chapter given, you please revise it. So revise this chapter. Exclusively the table, means the 11 methods that we have written, those 11 methods plus their example and their principle. This thing you have to keep in mind. Okay, student? So please do this much. Then again tomorrow we will meet to finish this chapter. Okay, student? आपको यदि आप यदि प्रैक्टिस कर सकते हैं तो मैथ्स के थोड़े से अपने बुक से एक बार और भी प्रैक्टिस करिए. Otherwise later on we will go for mathematics. Means after tomorrow we may start the new chapter of mathematics also. Okay, student? So this way we shall stop the class here itself. किसी को डाउट है तो बोलिए, नहीं तो हम क्लास यहाँ स्टॉप करते